All right, today we're going to take a little trip. A very unlikely trip, deep into one of the universe's biggest, baddest mysteries. We're going to tackle a question that is, well, equal parts mind-bending and absolutely terrifying. What actually happens if you fall into a black hole? So, yeah, let's just dive right in. No messing around. We're going straight for that classic cosmic question: what really happens when you finally cross that point of no return? And there it is, the big one. Just picture it for a second. You're out there in your spaceship, you make one tiny wrong turn, and suddenly you're drifting towards it. What is your fate? What's going to happen? And there's your answer. Probably not what you were expecting, right? For one very, very brief moment, everything's totally fine. And then, well, you become the universe's least appetizing pasta dish. So let's unpack how that even works. Okay, before we get to the whole, human noodles situation, we've got to clear something really important up about what black holes actually are, because they are seriously misunderstood, and getting this right is the key to everything else. So first things first, black holes do not suck. That is a huge pop culture myth. They aren't these cosmic vacuum cleaners just gobbling everything up in sight. Nope. They're really just objects with an absolutely insane amount of gravity. You have to get pretty darn close to actually get caught in their pull. And when I say insane gravity, I mean it. It's so extreme that it creates this boundary called the event horizon. And that is a literal point of no return. Once you cross that line, nothing gets out. Not your ship, not a planet, not even light itself. That's the kind of force we are dealing with here. Okay, so now that we know it's all about gravity, let's get to the main event, shall we? How exactly does a person become cosmic pasta? Yup, you heard that right. That is the actual official scientific term for it, spaghettification. It's literally what happens when the pull of gravity is so uneven that it just, well, it stretches and squishes you into a long, thin, noodle-like shape. So here's how it plays out. Imagine you're falling in feet first. As you get closer, the gravitational pull on your feet becomes way, way stronger than the pull on your head. And this huge difference in force just pulls you apart. It stretches you longer and thinner and longer until, well, you get the picture. You've just got to love the sense of humor astronomers have, right? They're faced with one of the most violent, bizarre ways a person could possibly die, and they give it a name that sounds like it should be on a restaurant menu. It's a pretty great way to make a terrifying concept a little more memorable. But wait, it gets weirder. If being stretched into a string of atoms wasn't strange enough for you, let's talk about what happens to time. Because near a black hole, the actual fabric of space-time gets all twisted up in the most unbelievable way. And this is a great way to think about it. In a super intense gravitational field, time itself slows to a crawl. Now for you, the unlucky traveler, everything would feel totally normal. But for anyone watching you from a safe distance, it's a completely different story. And this is where things get truly paradoxical. From your point of view, as you fall in, you would literally see the rest of the universe speed up, the whole future flashing before your eyes. But from where we're standing, watching safely from our spaceship, we just see you slow down, get dimmer and redder, and then just seem to freeze at the edge forever. So, let's put these two totally wild ideas together, spaghettification and time slowing down, to see what the truly mind-shattering conclusion to your little trip is. I mean, what does it even mean to be frozen in time while also being pulled apart? Because time slows down to basically a full stop for you. From our perspective, we would never actually see you cross the event horizon. We would just see your image stuck right there on the boundary for all of eternity. To us, your fall never, ever finishes. So you get this totally bizarre contradiction. In your reality, your journey ends pretty fast and pretty messily. But in our reality, your journey never ends at all. You just fall and fall and fall forever. And that's really the final cosmic punchline, isn't it? There's no coming back from this one, no respawning. Your story just gets locked in this weird paradox at the very edge of space and time. A permanent monument to just how strange the rules of our universe can be. And that is the question we're going to leave you with. It's really a question about reality itself. I mean, if we never see your journey finish, in what sense did it truly happen? It's one of those deep, deep puzzles that makes black holes the most fascinating and, frankly, the most terrifying objects in the entire cosmos.